Now let's go to subtopic 3.2, which is about periodicity in the periodic table of elements. So this is what you need to learn in subtopic 3.2. I know that it is quite a lot. So by the end of the lessons, you should know how to describe and analyze the variation in atomic radii across a period, across the first row of transition elements down a group. Compare the atomic radius of an element and its corresponding ionic radius. Define the term isoelectronic. Compare the radius of isoelectronic species. Analyze the variation in the ionic radii across period 2 and 3. Define the first and second ionization energies. Analyze the variation in the first ionization energy across a period and down a group. Explain the increase in the successive ionization energies of an element. Deduce the electronic configuration of an element and its position in the periodic table based on successive ionization energy data. Define electronegativity. Explain the variation in electronegativity of elements. And lastly, explain the acid-base character of oxides of elements in period 3. I know that it is quite a lot, but I am going to explain to you part by part. So in this section, I would like to describe and analyze the variation in atomic radii across a period, across the first row of transition elements and down a group of the periodic table of elements. Okay, dalam periodic table of elements, masing-masing atom semua ada masing-masing punya size. Okay, so macam mana you tahu size of the atom? Size of the atom tu diambil melalui atomic radii. So how do you want to know the atomic radii? Okay, the radius of the atoms diambil bila, let's say, atom tu dia duduk sebelah-sebelah. Identical atom tu duduk sebelah-sebelah, so half the distance between two of the identical atoms, we call it as radius. So macam tu lah radius of atom diambil. Tapi basically you tak perlu tahu pun this equation. Okay, contohnya, if let's say dalam periodic table of elements, kenapa you kena tahu the variation in atomic radii? It is because dia akan menentukan the size of the atom down the group or across the period. Okay, if you look at here, down the group, the size of the atom makin lama makin membesar. Okay, and then across the period, the size of the atom makin lama makin mengecil. Kenapa tu? Okay, tadi Miss ada tunjukkan ada saiz yang pelbagai-bagai atom di dalam periodic table of element. Okay, apakah faktor yang menyebabkan saiz yang berbeza-beza di dalam periodic table of elements? Okay, so ada dua main factors, which is the first one is the effective nuclear charge, or we call it as ZEF. This is the symbol untuk effective nuclear charge. And the second one is the shielding effect. What is effective nuclear charge or symbol ZEF? Okay, effective nuclear charge ni kita tengah bercakap mengenai charge yang di-experience oleh elektron disebabkan oleh shielding effects by another electron. So what is that? Okay, electrons moving around the nucleus tiada sama nucleus attraction mereka. So contohnya, if let's say you ada atomic model where this is the nucleus and ada orbit yang mengelilingi nucleus kan. Okay, so bila let's say elektron tu mengelilingi nucleus, kan ada nucleus attraction between dorang dua. That nuclear attraction kita panggil sebagai ZEF or effective nuclear charge. It is the charge bila electron to experience when it's orbiting around the nucleus. Okay, basically effective nuclear charge, we are talking about the nucleus attraction between nucleus dan juga elektron. Okay, sebab apa? Sebab bila elektron tu dia berada close to the nucleus, berada dekat dengan nucleus, dia akan experience a greater nucleus attraction. Okay, bila dia experience greater nucleus attraction, therefore ZEF, okay, effective nuclear charge for this electron is greater as well. Alright, okay. But what if you ada electron yang far away from the nucleus? If you ada electron yang far away from the nucleus, dia punya attraction between the electron yang far from the nucleus ni dengan nucleus ni, the nucleus attraction akan lemah. Okay, dia akan ada less nucleus attraction. So bila dia punya nuclear attraction dia lemah, okay, therefore the ZEF untuk those electron dan juga nucleus punya attraction akan rendah juga. Okay, so pokok pangkalnya ZEV dia akan depends kepada nucleus attraction. Okay, nucleus attraction ni pula ialah the attraction between nucleus and electrons. So itu apa yang penting dekat ZEV lah, which is nucleus attraction. Mathematically, you can calculate the effective nuclear charge, ZEV. Okay, macam mana you nak calculate ZEV? You boleh guna this formula. ZEV equals to Z minus S. Z adalah number of proton, S adalah bilangan electrons yang berada di inner orbital. Okay, nanti kita akan discuss more about this. Tadi kita dah cakap faktor yang mempengaruhi saiz sesebuah atom dekat periodic table of elements. One of it ialah ZEV, which is effective nuclear charge. Okay, the second one is the shielding effect. It is also known as screening effect. So, kiranya dua ni adalah benda yang sama. So, shielding effect ni apa? Okay, if let's say you ada atomic model where you ada nucleus and you akan ada orbital around it, right? Okay, so if let's say you ada orbital around and the valence electrons mestilah berada di valence shell kan. So outer electrons ni adalah nama lain untuk valence shell, sebab valence shell ni di mana valence electron berada. Okay, so selain daripada orbit valence shell, we call ada other shell yang sebelum outer electrons ataupun outer shell, we call it as inner shell. Okay, so this will be inner shell. Okay, sebab dia berada di dalam, dia bukan berada di luar. So shielding effect ni apa yang berlaku? It is actually caused when there is a mutual repulsion between electrons yang berada pada inner shell, ni electrons yang berada pada inner shell dengan electrons yang berada pada outer shell, berada pada valence shell. Okay, kiranya because of this mutual repulsion between electrons di inner shell dengan valence electron, therefore itulah dia, we call it as shielding effect. Okay, and actually the shielding effect can be also occurred between the electrons yang ada di shell yang sama, tapi taklah sekuat the repulsion between electrons yang berada pada inner shell dengan electrons berada pada outer shell. Okay, kiranya it is less effective. Okay, although ada repulsion between the same electron dan between electrons yang berada di same shell, tetapi dia less effective dengan repulsion between different shell. Okay. Sebagai contoh, kalau let's say you ada dua atom kat sini, atom sodium and potassium. Okay, masing-masing ada electronic configuration SPDF notation yang berbeza. Na sebab dia ada 11 elektron, so kalau ikutkan SPDF notation and if you ikut Aufbau principle, you will fill it in from 1s2 to s2 to p6, 3s1. Untuk potassium pula, it will start from 1s2 to s2 to p6, 3s2, 3p6, 4s1. Okay, so if let's say ini adalah atomic model untuk sodium and potassium respectively. Okay, ini adalah nucleus, ini energy level n equals to 1. Which belong to 1s2, so you ada 2 elektron saja. Energy level ataupun shell n equals to 2 ada sebanyak 8 elektron. So the outermost shell, which is the valence shell, terletak pada energy level n equals to 3, which 3s, okay, ada satu sahaja elektron. Okay, tapi compared to atomic model untuk potassium, okay, dia ada pertambahan pertambahan shell kat situ kan, sebab compared to Na, the valence shell hanyalah pada 3s1, tapi K ada pertambahan N shell, dia punya outermost shell dia berada pada 4s1. Jadi inner shell dia you akan ada energy level n equals to 1, n equals to 2, n equals to 3. Okay, this is n equals to 4. So, if you compare to Na, sodium, inner shell dia ada energy level n equals to 1, n equals to 2. Untuk potassium, energy level for the inner shell adalah n equals to 1, n equals to 2, n equals to 3. Okay, so apa yang berlaku kat sini? Therefore, shielding effect, okay, shielding effect ni dia bergantung pada inner electrons ataupun inner shells. Okay, so kalau let's say semakin banyak inner shells, semakin kuat shielding effect. So therefore, if you look at potassium, because potassium ada banyak inner shell, so shielding effect of potassium akan lagi tinggi compared to sodium. Okay, sebab shielding effect of valence electrons of Na is less than potassium. Okay, sebab potassium ada extra shell, sodium shell dia sampai 3 saja. Therefore, when n increase, bila number of shell increase in the valence electron, the shielding effect will be increased as well. Okay. Tadi Miss dah cakap faktor-faktor yang mempengaruhi size in the atoms of the elements dalam periodic table of elements. Sebab kenapa? Sebab dekat periodic table of elements dia ada trend of size untuk atom ataupun elemen dekat periodic table of element. Contohnya, there is variation in atomic radii across a period. Okay, across a period, if you tengok periodic table of element, it will be going from left to right. Okay, so from left to right, actually size of atom makin lama makin kecil. The atomic radius of elements will be decreases. Why is that so? Okay, kenapa trend across a period the size of the atom akan mengecil? Kenapa? Sebab across the period, okay, the proton number will increase. So, bila proton number increase, number of proton pun increase lah kan? So, bila proton number increase, actually the effective nuclear charge will increase. Okay? So, bila effective nuclear charge increase, okay, when we are talking about effective nuclear charge, we are talking about the attraction between nucleus and the electrons. Therefore, bila ZEF increase, the attraction of nucleus dengan valence electron becomes stronger. So, bila attraction tu become stronger, makanya the valence shell akan tertarik inward. Dia akan menarik ke dalam supaya dia jadi bertambah close, bertambah dekat dengan nucleus. Okay, therefore size of the atoms will decrease. Okay, shielding effect tak main peranan pun sebab number of shell tak akan berubah. Okay, tadi kan Miss cakap ada dua je faktor yang mempengaruhi size of the atom, sama ada ZEF ataupun shielding effect. Tapi kalau across a period, kalau size kecil, makanya ZEF yang main peranan. ZEF adalah attraction between nucleus dan juga valence electron. So attraction between nucleus dengan valence electron. Okay, so bila ZEF tu dia tinggi, makanya the attraction between nucleus dan valence electron akan makin mengecil. So therefore dia akan kecilkan the shell of the valence electron. So makin lama makin kecil. So that's why size pun mengecil. Okay, kenapa shielding effect tak main peranan? Okay, shielding effect tak main peranan sebab kalau across the period, for sure lah the number of shell dia akan always sama, n equals to 3 kan. Mestilah number of shell across the period, contohnya you ada A, B, C, D, E. So mestilah sudah tentunya kalau across the period, kenapa dapat period yang sama? Because if you buat SPDF notation, mesti you dapat the valence electrons atau the valence shell akan berada pada energy level n equals to 3 untuk kesemua elemen ni. So number of shell tak berubah. Kan tadi kita dah bincang, kalau let's say nak cakap pasal shielding effect, kena ada perubahan number of shell untuk valence electron. Okay, so since kalau across the period number of shells tak berubah, sama sahaja, Therefore, shielding effect tak main peranan. Okay. Saiz mengecil sebab ZEF kuat. Bila ZEF dia strong, makanya the attraction between nucleus and the valence electron and the valence shell pun stronger. So, bila attraction dia kuat, maka dia akan force the valence shell makin lama makin mengecil. Therefore, across the period, size of the atom makin lama makin mengecil. Because apa? Sebab ZEF. Okay, the key word here that you need to remember, kalau let's say across the period, you need to remember P ZAS. Okay, so you can include every points di P ZAS ni. P apa? Bila across the period, proton number increase, therefore effective nuclear charge akan increase. The attraction, A untuk attraction. So therefore the force of attraction between nucleus and outermost electrons are getting stronger. And therefore, lastly, the size of the atom across the period are getting smaller. Okay, so bila you nak explain point kenapa across the period the radius, atomic radius of the elements it decreases is because you ingat this key point P ZAS. So you kena include keempat-empat point ni, okay, untuk dapatkan markah. So, if let's say you tak percaya kan, you pun nak buatlah calculation ZEF ni across the period. Kenapa ZEF ni increase ke and atomic radius decrease. So, you boleh buat mathematically. You know that ZF is equal to Z minus S. Z adalah proton number, S adalah number of inner electrons. So, untuk kira ZEF, contohnya if given period yang ketiga. So, period yang ketiga, we will have Mg, Al, Si, and P across the period. Alright. So, this is the number atas ni adalah proton number. And then, untuk tahu the number of inner electrons, you kena buat electronic configuration. Okay. So, you have to do the electronic configuration so that you can figure out the number of inner electrons. Okay. So, contohnya, if you look at the Mg ada proton sebanyak 12 and bila you buat electronic configuration for Mg, you will get 1s2, 2s2, 2p6, 3s2. Therefore, 3s2 will be the valence electron. Since 3s2 jadi valence electron, makanya 1s2, 2s2, 2p6 ni akan jadi S, akan jadi inner electrons. So, bila kamu nak kira ZEF, it will be proton number tolakkan dengan number of inner electrons. So, you kira berapa number of inner electrons untuk magnesium? 6 campur 2, 8 campur 2, 10. So, 12 minus with 10, then you will get 2. Okay. So, ZEF untuk Mg kan awal-awal sikit kat periodic table of elements kan. So, if let's say you ada periodic table of element, I believe that Mg is located around here. Okay. So, therefore, Mg size dia besar sikit. Okay. Next ialah across the period kan. Across period 3. You akan jumpa aluminium. Aluminium dia mempunyai electronic configuration 1s2, 2s2, 2p6, 3s2, 3p1. Therefore, this is the valence electron, valence shell electron, and this is the S untuk aluminium. Okay. Sama juga ada 10 elektron di inner orbital untuk aluminium. Tapi number of proton berbeza, 13 minus with 10, positive 3. So, kan kita dah cakap bila ZEF increases, atomic radius decreases. So, bila ZEF increase, atomic radius makin lama makin kecil. And if you go to Si, you will know that the Si ni, this is the valence electron, valence shell. This is the S. Okay. So 14 tolak dengan 10 dapat positive 4. So you can see here, you can see down the across the period. Okay, across the period, ZEF dia memang makin lama makin meningkat and it is proven mathematically. Okay, so bila ZEF increase, size akan decrease. Kenapa size decrease? Size decrease sebab nucleus attraction, ya. You kena ingat this point, nucleus attraction. Kan tadi kan Miss ada cakap kalau kamu nak terangkan variation in atomic radii across the period, ingatlah phases. Sebab if you look at this, across the period, this is across the period, ya. Across the period, number of proton dia makin bertambah, kan? So proton makin bertambah. Bila proton pun makin bertambah, makanya ZEF pun akan makin bertambah. Nucleus attractions between electron, valence electron dan juga nukleus pun akan makin kuat. Therefore, size of the atom across the period akan makin mengecil, makin mengurang. Next, let us discuss about the trend of the size of the atom across the first row of transition elements. This is the first row of transition elements berada di period yang keempat, 1, 2, 3, 4. Block D, group pula ialah from group 3 until 12. So, diorang akan ada electronic configuration from AR for S2 3D1 until AR for S2 3D10. So, if you look at the trend on the atomic radius across the first row of transition elements, the atomic radius almost constant across the period. Why? Why is that so? Okay, kenapa atomic radius across the first row of transition elements is almost constant? Why? Sebab, okay, across the first row of the transition elements, the electrons will be added to the inner 3D subshell. Okay, dia akan added to the inner subshell. Bukan, sebab kan bila kamu add electron kan, kamu akan add dekat 4s dahulu, baru 3D. So 4s akan remain constant, 4s2. 3D akan berubah. Kalau let's say 4sc, you akan dapat 4s2 3D1. Kalau TI, you akan dapat 4s2 3D2. And so on. Sampailah Zn, you akan dapat 4s2 3D10. So, kamu akan add the electron pada inner subshell. Okay. And the 4s orbital akan remain constant. Alright. And because the inner 3D electrons, they shield the outer 4s electrons from the nuclear charge more effectively than the outer shell electrons. Therefore, the effective nuclear charge will be cancelled out by the screening effect of the electrons in 3D orbitals. Okay, so kiranya ZEF will be cancelled out. Okay, and the outermost shell electrons will experience a similar force of attraction to the nucleus. Okay. Therefore, ZEF will be constant. Therefore, atomic radii does not change very much. So, if you tak boleh nampak ni, nanti kita Miss akan bagi illustration on this explanation later. Across the first row of transition elements, the size of the atom lebih kurang sama saja. Okay, sebab apa? Okay. If let's say you ada element Sc up until zinc with this respective number of protons for each of them with respective electron arrangement, which is lebih kurang sama sahaja 1s2, 2s2, 2p6, 3s2, 3p6, cuma yang membawa perubahan hanyalah bila kamu isi 3D. Okay, 4s remain the same, 4s2 remain the same, sebab memang kamu kalau ikutkan aufbau, you need to fill in the 4s dahulu barulah 3D. So that's why 4s2 remain the same. Yang berubah hanyalah 3D. Okay. Cumanya kat sini adalah anomalous dekat CR dan CU kan. So you tengok dekat simplified. You can just simplify by letak noble gas argon, sebab argon ada 18 elektron, sebab daripada dia mempunyai electronic configuration from 1s2 until 3p6. That is argon. So if you want to simplify it, you can just write down Ar, and if you look at here, the 4s2 remain constant sebab memang you add electron dekat 4s2. So baki-saki-baki, you akan add pada inner subshell 3D orbitals. Okay, tadi kan Miss ada cakap kan, effective nuclear charge constant dekat first row of transition elements. Alright, so if you tak percaya, you boleh cari dia punya effective nuclear charge by using this formula ZF equals to proton number tolakkan dengan inner shell. Okay, so for example, element SC, okay, if let's say you buatlah electronic configuration yang panjang-panjang, you ada 1s2, 2s2, 2p6, 3s2, 3p6, and then 4s2, 3d1. Okay, so if you look at the inner shell, it will be from actually 1s2, 2s2, 2p6, 3s2, 3p6, 4s sampai 3d1. Okay, 4s ni outer shell, alright. 3d ni inner subshell, tapi sebabkan outbound, that's why 3d ni terkeluar. Tapi kalau nak ikutkan, 3d ni adalah inner subshell. Okay, tapi bila nak isi elektron, kamu isi 4s dahulu, barulah 3d. Alright, so if you look at here, the inner electron untuk SC will be 19. Sebab you kira ni 2, 4, 10, 12, 18, 19. So inner electron untuk SC ada 19. So proton number of SC 21 minuskan dengan minus with 19, you will get positive 2. Okay, same goes to TI. Sama juga, dia punya inner shell dia, it will be from 1s2, 2s2, 2p6, 3s2, 3p6, 3d2, 4s2. Kiranya 18 sebab argon ada 18 elektron kan. 18 campurkan dengan 2. So ada 20 inner elektron untuk titanium. Proton, so nak kira effective nuclear charge untuk TI, it will be 20 minus with 22, which you will get positive 2. Okay, so kiranya you tak kira lah, you kira daripada SC sampailah Zn, dia punya effective nuclear charge untuk the first row of transition elements in the periodic table of elements sama sahaja. Bila ZF dia constant, that's why lah the size of the atoms in the first row of transition elements in periodic table of element lebih kurang sama. Okay, sebab ZF constant. Okay, Miss ambil contoh lah ya. Contohnya Miss ambil zinc. Zinc adalah tergolong daripada salah satu elemen dekat first row of the transition elements in the periodic table of elements. Zinc ada 30 protons, therefore dia ada 30 electrons. Jadi bila Miss buat electronic configuration dia, I will get something like this. Okay, apa-apa pun, I will have to add the electron in 4s orbital barulah 3D. Okay, so to simplify, I can write down something like this: AR 4s2 3d10, ataupun AR 3d10 4s2. Kalau ikutkan afbau, memanglah afbau suruh isi dekat 4s baru 3d. Tetapi actually 3D tergolong dalam inner subshell. Okay, sebab itulah electronic configuration tu berbentuk macam ni. Tapi apa-apa pun yang ni memang Miss isi dekat 4s dulu baru 3D. So kalau ikutkan dekat transition element ni, the first row of transition element, memang kan tadi kita dah tengok previously the electronic configuration dia 4s2 remain constant, yang berubah adalah 3d because you akan add electron pada 3d inner 3d subshell. So if let's say this is the atomic model untuk transition element where you have nucleus and then ada energy level ataupun shell, n equals to 1, n equals to 2, n equals to 3, n equals to 4. N equals to 1 ada 2 electron because you will only have 1s2. Bila n equals to 2, you will have 2s and 2p. So total electron ada 8, 2, 4, 6, 8 kan. Untuk 3, energy level n equals to 3, you ada 18 elektron. 10 campur 8, 18 kan. Tapi 3s dengan 3p ni kita tak add apa-apa elektron dekat situ. Kita hanya bertambahkan elektron pada 3d. Okay, and you will have the last shell here which is 4s. 4s shell, which you will have only 2 electrons. Okay, kat sini, number of electrons in the outermost shell remains the same, ada 2 elektron. Walaupun number of protons bertambah, sepatutnya ZF kena increase lah kan. Tapi you tak add elektron dekat energy level n equals to 4. You add dekat energy level n equals to 3. You add pada siapa? Dekat 3D. Okay? Electrons in 3D orbitals, bila you add electrons dekat 3D, electrons dekat 3D orbital ni dia akan shield, dia akan protect. Dia akan protect the nucleus, dia akan protect elektron dekat valence elektron ni nak mengecil, okay? Dia akan protect. So, electrons dekat 3D orbital ni, dia akan shield the valence electrons in 4s orbital. Bila let's say you keep on tambah elektron, makin protected lah 3D ni, okay? Makin bertambah kuat lah shielding effect. Sebab apa bertambah kuat? Sebab you keep on adding the electron. Bila although proton number bertambah, tapi you keep adding the electron dekat energy level n equals to 3. Okay? Therefore, electrons dekat 3D orbitals, dia akan shield the valence electrons in 4s orbital. Okay? Sebab bila dia shield, elektron dekat valence electron tak boleh lah attracted pada nucleus. So, the effect, because of this, the effect of increased nuclear charge, ZF, will be cancelled. Although the number of protons increase, ZF akan increase kan? Tetapi ZF ni dia akan cancel out by the screening effect of the electrons in the 3D orbitals. Okay? So, apa yang berlaku dekat transition elements ni, although number of proton makin meningkat, ZF pun akan meningkat, tapi ZF ni akan di-cancel out by the shielding effect of the electrons in the 3D orbitals. Okay, so the outermost shell electrons, outermost shell n equals to 4 ni, the electrons, the valence electrons lah, akan experience a similar force of attraction to the nucleus. Sebabkan ada shielding effect yang kuat dekat 3D, makanya the attraction between the outermost shell dengan nucleus akan lebih kurang sama sahaja. Okay, therefore the atomic radius will not change much. Okay, senang cerita, across the first row of transition elements, okay, the atomic radii will not increase much from copper to zinc due to more effective shielding effect and the increase in the electron-electron repulsion as the 3D orbitals becomes completely occupied. Alright? The last one, I would like to discuss the trend of atomic radii down a group. Okay, bila down the group, bila proton number increase, atomic radius akan increase. Okay, if you look at dekat group 1 ni, makin ke bawah, makin bertambahkan proton number. Makin bertambah proton number, makin besar atom tersebut. Macam kat group 17 juga. Makin bertambah proton number, makin besar atom tersebut. Although 1 dengan 17, group dia 17 ni jauh ke belakang kan. Tapi kalau let's say down the group, memang atomic radius akan increase. Why? Okay, so sebagai contoh, if let's say Miss ambil contoh down a group 1, okay, this is group 1 punya elements where ada daripada hydrogen sampai CS, okay, which with dorang punya respective proton number. If I buat electronic configuration berdasarkan proton number for each of these elements, I can see the trend where the number of the valence shell makin lama makin bertambah. Right, so what do I tell you just now? If let's say the number of valence shell bertambah, dia akan mempengaruhi shielding effect. So apa kena mengena dengan size? So how can you explain if let's say bila you makin turun dekat dalam group tu, makin menurun, the atomic radius makin bertambah. Dia punya size makin membesar. Sebab apa? So this is the explanation. So when going down the group, the number of electron shell akan bertambah, kan? So n increases. you will have a larger value of N. Therefore, terlampau banyak inner electrons, okay, yang akan shield, yang akan protect. Terlampau banyak is, let's say this is the nucleus and this is the inner electron. If let's say you ambil cesium, kan you ada 1, 2, energy level N equals to 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6. Terlampau banyak sangat inner electron. This is the valence electron. Valence electron ataupun valence shell. So meanwhile, terlampau banyak sangat dia punya inner orbital yang melindungi outer electron untuk apa? Untuk attract the nucleus. Okay. So therefore, terlampau banyak sangat inner electrons yang shielding the valence electron from nuclear charge, as there are more completed electron shells between the valence electrons and the nucleus. Okay. Therefore, the shielding effect akan bertambah. The shielding effect of the valence electrons will be increases. So bila shielding effect increases, makanya the nuclear charge akan jadi lemah sebab tak boleh nak attract the valence dengan nucleus kan. Nuclear charge lemah. So therefore, the size of atoms pun akan bertambah. Okay. So bila let's say size atom tu besar, apakah faktor yang mainkan peranan? Faktor yang memainkan peranan bila atomic size tu besar, if let's say the size of atom besar, the factor yang affect the size yang besar adalah we call as shielding effect. Okay. Kalau saiz kecil, kita guna point Z. Kalau saiz besar, kita guna point shielding effect. Okay. Sebab apa? It's all about the attraction between the nucleus and the valence electron. So kalau let's say the attraction between nucleus and the valence electron terlampau banyak sangat inner orbital kan. So if let's say the punya attraction between nucleus and the valence sangat-sangat lemah, it is because of kehadiran terlampau banyak sangat inner shells. Sebab apa? Sebab shielding effect. Okay. Tapi kalau saiz kecil, sebab apa? Sebab the nuclear charge tinggi. Sebab kenapa nuclear charge tinggi? Sebab the ZEF, the effective nuclear charge tinggi. Sebab terlampau kuat sangat attraction between nucleus and the valence electrons. Okay. So in this case, kalau down the group, saiz besar sebab shielding effect besar. Kenapa shielding effect besar? Sebab terlampau banyak sangat inner shells. Okay. Therefore, the nuclear attraction between nucleus and also the valence electrons kurang. Okay. Dia lemah. So that's why the size of the atom increases down a group. Untuk tak nak tertinggal satu pun point, kenapa bila going down the group, the size of the atom increase atau size atom tu besar, you boleh ingat this keyword N size. N stands for bila going down the group, the principal quantum number ataupun number of shells akan increase. Bila number of shells increase, shielding effect of the atoms pun akan increase bila going down the group. Therefore, bila shielding effect increase, you akan tahulah the force of attraction between nucleus and the outermost electron are getting weaker. And lastly, that's why lah size of the atom increases when going down the group. So to conclude, you kena ingat ni kalau let's say size of atom ni bila going down the group makin lama makin besar. Sebab apa? You ingat key point N size. Okay. The higher the principal quantum number, the larger the shielding effect. Therefore, the attraction between nucleus and the valence outermost electrons makin lemah. That's why size dia makin besar. The larger the atomic radius. Tapi kalau across the period, the size makin lama makin mengecil. Sebab apa? You ingat pizas. Apa tu pizas? Bila across the period, proton number. Proton number bukan number of shell yang increase. Proton number increase. Therefore, the effective nuclear charge increase. Bila effective nuclear charge increase, the attraction between nucleus and the outermost shell akan increase. That's why across a period, the size of the atom is small.